those other vehicles.
Okay, our next question's here in the front.
Hi, Phillips Loss. One question for Judd. Are you going to plan on doing an OTC3 burn, or is it possible to delete that as well? And then for Dr. Young, just to clarify, the eclipse, the 53-minute long eclipses, where is that in that 3-hour flyby window? Thank you.
So currently, OTC, the outbound trajectory correction number 3, we do plan to do that based on our current numbers. So, and we'll do that with the SM reaction control system.
And the eclipse, so the fly-by-day profile will look like a roughly 5-hour period where the crew is observing the moon. Like in the video you guys saw, they'll see the illuminated surface of the moon. And then a short time after Earthrise, we will kind of have a break in lunar viewing attitude where they'll be doing some other tasks before then pivoting back to look at the eclipse. So the 53-minute eclipse is roughly, an hour after Earthrise at the end of the flyby window.
Thank you. Next up, Jackie.
Hi there, Jackie Waddles with CNN. Another question for Dr. Young. I just wanted to ask, because the president's budget request came out yesterday, and we saw another proposal to cut 47% of NASA's science budget. I just wanted to ask you, how are you thinking about how that changes the agency's science initiatives and even some programs that help support Artemis, even though I know Artemis had an increase in funding. And also would just love to know how that's affecting employee morale and what you're doing to kind of keep employees happy. Thanks.
Our briefing today is focused on Artemis 2. Our budget numbers are available online at nasa.gov/budget. If you guys have any additional questions, you can reach out to Public Affairs after about the budget. Thanks. Let's go to another question in the second row. Yes.
Thank you. Tarek Malik with Space.com for Dr. Young. When we spoke back in September, there was a lot of uncertainty about what the crew would be able to see during the flyby coming up, and I imagine that kind of came down to the launch on April 1st. So I'm really curious, given that they're going through their targets today, their geography and whatnot, what you are hoping, I guess, to see, or what they're looking at the most in terms of what they have to practice, and then how do you keep them not looking at the moon outside of that 5-hour period as they're on approach and on the way out? Thanks.
Relatable question. Absolutely. So it was a really interesting challenge, and we did speak back in September about how to scope the flyby, given that, what targets will be visible to them are entirely dependent on when exactly they arrive at the moon, right? At any given moment in time, 180 degrees of the moon is illuminated and 180 degrees is not. And so what we did was we actually built a list of targets or features on the lunar surface for the entire 360 degrees of the moon, because we knew that once they launched and we realized when they'd get there, we'd be able to narrow down what was visible and from there prioritize based on our science objectives. And so as we were getting closer to this April launch window, we were building out that target list of how we would prioritize, launching throughout the April launch window. And then ultimately, of course, we launched on April 1st. So actually yesterday, the science evaluation room, the room that was showed earlier on screen, you can bring it up now again if you'd like, they were working to basically finalize that list of lunar targets that will ultimately go up to the crew and be executed on Monday. So what the crew are studying today is like the 80% solution. It's a study guide, and then tonight the final targeting plan will get uplinked to them, and they will review that prior to the flyby on Monday. And so we really, in that way, are able to maximize the science that we're getting out of the flyby by waiting until we know exactly when we're going to get there and maximizing the science out of that specific illumination profile that are presented to us. So I'll say that, the last part of your question about kind of where has the most effort gone into, I'd say we had done a lot of planning for months on the targets of interest on the illuminated lunar surface. The eclipse, we really started to focus on in the last few weeks. And so we put a lot of effort into fleshing out those prompts, because ultimately the crew, to execute this plan, will be looking at their lunar targeting plan on their crew tablets and executing target by target by target based around prompts that the science team provides to them. So we put a lot of effort in the last several weeks into eclipse planning, in addition to continuing to flesh out the lunar targets in their own right.
We are going to take a few questions from our phone bridge next. If you are on the phone and you have a question, reminder to please press *1 to get into the queue. We'll start with Nell Greenfield-Boyce with NPR.
For taking my question. This is another science-related question. You talked about maximizing the science. Could you talk about, actually the science questions that you want to address, for example, with the eclipse? I'm not clear. Have people seen an eclipse like this before? And if not, what will the astronauts be able to contribute that would tell you something about, the sun? What are the actual science questions? And similarly, with the lunar targets, I guess, people on the street might feel like, well, don't we have a lot of pictures of the moon and orbiters and things like that? What are the actual questions? What is being maximized in terms of what you'll be able to know based on what the astronauts are doing? Thank you.
Oh, I'm so glad somebody asked me about science objectives. Absolutely. We have, like I said, 10 lunar and planetary and solar system science questions for the mission that ultimately feed our targeting plan. So I'm going to take your question in two halves. The first part of your question was eclipse focused. Yes, Apollo crews saw similar eclipses, which again, in this context means that from the vantage point of the crew capsule, the moon is blocking the sun from view. What's different about the eclipse for the crew here is that, for us, I don't know if any of you saw any of the total solar eclipses over the last few years. Actually, we're coming up on the 2-year anniversary of the North American eclipse from 2024. What's unique about viewing eclipses from the Earth's surface is that from our vantage point, the moon and the sun in the sky appear approximately the same size. And that's why you can see that beautiful ring of fire when the moon moves, takes center stage in front of the sun. Of course, Integrity has a much different view than we do. And so the moon appears much, much, much larger in their view than it does from us here on Earth. And so that's why in that visual you saw earlier, the sun appears as a relatively small disk. And that means that instead of the ring of fire eclipse that we see here on Earth, they'll actually see the solar corona, but only part of it. And so we have science questions designed around looking at solar activity at the time of the eclipse. And so they'll actually be able to make, unique observations on Monday, April 6th, and what the sun is doing at the time. We've included prompts for them to describe the features that they can see in the solar corona, which can ultimately help solar scientists understand these processes in general, especially given the unique vantage point that the crew are going to have relative to our orbiting spacecraft here on Earth and our observers, our scientists here on Earth as well. Jumping to the second part of your question on just non-eclipse related science and lunar science, we took our driving science questions from our community documents, our Science Mission Directorate decadal surveys, which represent the highly prioritized science objectives that the entire community are driving toward. And what we did is prioritize them based on what Artemis II and our mission profile are really uniquely able to accomplish. For example, human beings are really good at making nuanced color observations. We have amazing camera data from decades of orbiting spacecraft, Lunar Reconnaissance Orbiter. I'm based at the Goddard Space Flight Center. I love LRO and all the data it's been able to tell us about lunar science. However, the human eye, especially when it's connected to a well-trained brain, which I assure you these 4 people have, are capable of just in literally the blink of an eye making nuanced color observations that Apollo observations told us can tell us something scientifically. When Jack Schmitt on Apollo 17 saw orange soil and he collected that sample, they launched back into orbit and saw that same orange hue from when they got, from the surface to when they went to orbit. That told us something that volcanic processes were active on the lunar surface much more recently than we had expected before. We're looking for the crew to take time during their flyby, let their eyes adjust to what they're seeing, and call out any of those subtle color nuances, especially on the parts of the far side that have never been seen before by human eyes. And we're able to ask more intelligent questions because of what Apollo gave us and because of what those orbiting spacecraft provided to us. Another example, and I swear I'll stop soon, you've got me all excited about the science, is photometry. And that's essentially taking advantage of differing illumination conditions throughout the flyby. And so the analogy I like to give, and we actually ran this exercise with the crew in training, is imagine a sandbox. You know that when you go to the beach, sand is not perfectly flat. There's texture. There's different particle sizes. turn off the lights in a room, look at that sandbox, shine a light shining directly on top of it, what you'll see is color. You'll see the shades of color and albedo on that surface. Take the same light source and move it to the side. You'll lose all the color nuance, but you will see topography and morphology. Comparing those two angles allows us scientifically to really understand lunar surface evolution. And though we can't move the sun in this mission, we can move integrity. And so by looking at the same targets more than once throughout their flyby, they'll be able to make observations about the same targets in different illumination conditions that would take some spacecraft days, months, weeks, years to build up. And the fact that they're able to see that in the duration of several hours can really help us dive deep on some of our really high priority driving lunar science questions.
Thanks, Kelsey. Next up, we'll go to the phone bridge. We have Lauren Grush with Bloomberg.
Hi, thank you so much. I think this question is for Debbie. I wanted to check back in about the isolated helium feed that was brought up yesterday. Just wanted to make sure that second line is still holding up okay. And I think I was a little confused about the answer that was given on the redundancy of that system if the second helium feed that's being used right now goes down. What did it mean that you don't need to regulate? I'm just wondering if I could get some more clarity on that. Thanks so much.
Sure, yeah. So as mentioned yesterday, I believe we did isolate one branch of our MON line as a part of the SM prop system, and we have not exactly determined what is happening there. We saw a little bit of pressure rise, which was higher than, or not in family with what we had seen in previous testing, and so we isolated that branch. The secondary branch is completely redundant and is completely operable right now, so we have no concerns about being able to operate the prop system. The remaining burns that we have actually don't require the helium pressurization into the MON system tank. The MON system tank is now holding an amount of helium that it already needs. It backfilled the prop it already used up with the helium, so it's already primed and be ready to go for the remaining burns that we would need. If we did have an issue on that branch, we can always go back to the other branch. Using the other branch is not precluded just because of this item that we saw, this feature. We just decided to isolate that one and use the from a health perspective, use the healthiest branch for any remaining burns. Those burns are really small. I'm sure Judd could speak more to what we have left to do, but that's why we said we don't need the helium pressurization anymore, because the MON tank already has the pressure in it that it needs to execute the remaining burns with, I think, 4 to 5 times more than we would actually need based on the predicted burns.
Yeah, I'll add, so the trajectory corrections that we have, we skipped the first 2. We got 4 planned remaining. Each one of those we budgeted maybe 30 seconds or so for, and we're really only seeing we only need probably 10 seconds at most, and so we've got plenty of ullage is what we call it. So plenty of pressurization in the system to not have to use the helium, even if we had a problem with the secondary line.
And I guess I should also mention we are also protecting for an off-nominal type of board situation. In that case, you may have to use a pressurization system, and the second branch is perfectly healthy to accommodate that as well. So we have not lost any redundancy or fault tolerance in our system. We decided to isolate the one branch that we didn't like the behavior and proceed with the rest of the mission on the secondary branch.
We'll take one more question from the phone before coming back into the room. Next up is Joseph Howlett with Scientific America.
Hi, yeah, this is for Kelsey. Curious if there's a particular lunar feature or another that you're excited to get human eyes on. Is there something that in particular that you're looking or hoping for the astronauts to see? And then also, have they gotten photographs of any other celestial bodies besides the moon already, or is that planned for the next couple days?
Yes. If you ask, 100 lunar scientists what their favorite features are, I'm sure you get 100 different answers. I think I'll maybe cheat and give a couple. I think Oriental is obviously extremely compelling. This is an impact basin that plays such a critical role in not just lunar science, but in planetary and solar system science. It's the type impact basin we use to understand impact processes across the solar system, which is one of the most ubiquitous processes across the entire solar system. And we've never had human eyes on by far the majority of it. I will say, a little bit closer to home, The crew is really excited about that target, and they're really excited about, understanding its significance in lunar science and planetary science. So I'm really eager to hear their descriptions, specifically of Oriental, just given the excitement that the lunar science team has and that the crew has. We also, when we were training the crew, we gave them a Big 15 lunar geography challenge. So we gave them 15 features across the entire surface of the moon that at any given time, no matter when they launched and what the illumination was, they'd be able to see at least 5 of them at the time. And so if you can, know these 15 features, you will always be able to orient yourself on the moon. One of our targets that they'll actually look at twice on Monday is Ohm Crater. That was one of the Big 15. They've used it as sort of this, quizzing themselves. We actually literally made them flashcards for understanding lunar geography. And so I'm excited that Ohm made it into the targeting plan and that they'll actually get to see it twice under different illumination conditions. So there's a lot of really exciting potential for the observations. And, frankly, what I'm the most excited about for Monday is hearing those descriptions starting to come down from the crew. They've practiced for many, many, many months on visualizations of the moon. Eyes on the real thing. Really, really looking forward to them bringing the moon a little closer to home on Monday.
Next up, Will.
Hi, Will Robinson-Smith with Spaceflight Now. Thank you all for taking the time. Question for John Honeycutt. In your mission management chair role, we heard early this morning when the crew first woke up, early days, but it sounded like there may be some weather in the splashdown zone that's being watched at this point. I wonder if you can give us the assessment at this phase of the mission, how the splashdown recovery is looking, and then putting your SLS hat back on. You mentioned earlier in your remarks, the rocket performed pretty straight down the middle and even better than Artemis 1. Even given that, are there some tweaks or finesses that you'd like to see between this rocket that just flew and the rocket that will fly on Artemis 3? Thanks.
So I'll take the first question as far as entry weather. So it's a little too far out right now for our models to converge. But I'll tell you, our meteorologists have been monitoring what we think the models are gonna do, and we're essentially in between two systems. And if those systems either speed up or slow down, then we might have a case where the weather might not be good in the San Diego area, and we might have to go a little bit more uprange into the Pacific. But again, those models it's too far out to know that. So we'll get better models Monday or Tuesday, and so that's when we'll plan to